Okay.
So this is the thermometer, and this is the oxygen analyzer, the digital volumetric flow meter, and the volumetric flow meter.
This is the distillate, you said?
Digital volumetric flow.
Digital?
Yeah.
Okay.
And this is the volumetric flow meter, which will the volumetric flow rate will be based on the number of the revolutions. For one revolution, it's 0.1 feet cube. Okay, and this one gives you the volumetric flow rate in liters per minute. You can convert the feet cube per revolution by timing that the time taken for one revolution, and using the conversion factors you can get it to liters per minute. Generally, these two will be close enough.
They'll be closed?
Yeah, they'll be close enough. Yeah.
Okay.
And this is the oxygen analyzer sensor. This one.
That's a sensor,
oxygen analyzer sensor.
Okay.
This is the analyzer, right? So the air comes to the sensor and it analyzes the percentage of oxygen present in the stream.
So what you're saying is that the air comes to here and they analyze the percent of oxygen that's in air.
Yeah.
Okay.
That's in the stream.
That's in the stream?
It can be the feed, the permeate, or the reject.
Okay.
It can be any stream.
So where do we turn it on? Is this the valve that...
This is all you turn it on here.
Oh, okay. So
This sensor, it's not on or off, but this one is on or off. Okay. So first thing you do is you calibrate this oxygen analyzer sensor.
okay.
Okay. So for calibration, this valve is for letting the stream into the feed stream into the apparatus. This valve, this black valve, and this green valve, right? Yeah. And this valve is for calibration purposes.
Okay.
Okay. So for your calibration, this should be off or closed all the way to the right, and this should be open.
All right.
Okay. So for your calibration, you calibrate it with air, then with oxygen, and then with nitrogen, and then to air. So for your calibration, you open this valve. Yeah.
But first we do air first, then
Yeah.
oxygen, then nitrogen,
Yeah.
and then we go back to air.
Yeah.
Okay.
So you open this,
Okay.
you pressurize this to 5 psi, and this one should give you 20.9.
20.9.
20.9.
Okay.
Because in general, the percentage of oxygen present in general air is 20.9, right?
About 21%.
And your feed stream is air.
Okay.
Okay. So if this one is not 20.9, you adjust it with the screwdriver. There is a hole present in there, and there is a screw in there. You adjust it to get 20.9, and then you close this, you depressurize this, you take off the hook, and proceed to oxygen. Again, open, pressurize to 5 psi, note down the reading. It should be around, theoretically it should be 100, right? Because that's an oxygen analyzer and this is oxygen
Yeah,
gas.
it should be.
Yeah, but practically it will be plus or minus 2 to 3%.
Okay. So once
Just
we get
write down the reading.
once we get that,
Yeah.
once we get the 100%, roughly about 100%, we do the same thing. Unplug this.
Yeah.
Destabilize.
Close this, depressurize this, then unplug it.
And then we do the same for
Nitrogen. Open, pressurize to 5 psi, note down the reading.
Should be about 79%.
No, 0. Because it's pure nitrogen, right?
Oh.
Yeah. Yeah.
Yes. I said 79%. Yeah, you're right.
I was like, wait a
So
minute.
yeah, it will not be 0, but it will give some reading. Note that reading now. Close it, depressurize it, plug it back to oxygen,
Okay.
air, and then I can open it, pressurize to 5 psi, and make sure that it's 20.9.
Okay.
Okay,
Yeah.
and then you proceed to your main trials.
We press the what?
Main trials.
What is-
Proceed to your main trials.
Okay.
For going to your main trials, that should be off. The cylinder should be off. Okay, you open this valve all the way to the left, and you close this one because the feed need to go into the apparatus.
All right. So
Right.
in this, like this, it's open
Yeah,
and it's closed.
written here, right? If it's not.
Oh. Yeah. Okay.
FDBC righty tight.
Yeah. So yeah, these two valve positions are important for changing from calibration to main trials. Okay, and this is a 3-point valve. The direction of the valve gives you the pressure of the stream. Okay, so if this is pointing upward, that means this is the feed stream light, right?
Mm-hmm.
So your feed is going into the membranes in this direction. So it's pointing towards the feed stream. So this gauge gives you the feed pressure. And if it's pointing downward, your feed is going in, your permeate is coming out from the membranes here, and your reject is coming out from here, right? And if it is pointing downward, it is connected to the reject stream. So if it's pointing downwards, this gives you the reject pressure. Okay. So for
So,
your main trials,
Quick question. Let's
Yeah.
go over it. So you said when it's pointing up,
yeah,
it's going to the permeates.
no, it's pointing towards the feed stream.
I'm sorry, it's pointing. Oh, so when it's pointing towards the feed stream. So these would be the feed streams right here.
No, this is the feed stream. These are the permeate out streams.
Okay.
You see that the permeates are coming out from the membrane here,
Okay.
right?
Okay, I see. All right.
Yeah,
Mhm.
permeate flow, right?
Mhm.
And this is your reject out. The reject pass through all the membranes, and then it comes out from here. Okay?
And that's how it would measure the pressure of the reject.
Yeah, here.
Okay.
Okay?
All right.
So your feed comes in here, and your permeate comes out here, and your reject comes out here. Right?
Oh, okay, makes sense.
And this is a control metering valve. You see this valve?
Mhm.
It has numbers on it, right?
Yeah.
It has numbers on the stainless steel thing and as well as the black thing, right?
Yeah.
The number on the stainless steel is the whole number, and the numbers on the black thing are the decimal places,
Mhm.
the 10th decimal place. So if it's at if it's at this position, it's 8.0. Okay.
8.0. Okay.
You see that the stainless steel,
Yeah, I see it right
it's
here.
at 8 and this is at 0, right?
So it'd be 8.0. Is it?
It's 8.0.
Yeah.
Okay.
Mhm.
So that's how you play with that. And these four are the toggle valves,
The what? The
the toggle
toggle.
valves. And the position of these four valves is really important for measuring the flow rates and the concentrations. Okay. So in general, let's just say, let's trace the flow paths. Your feed is coming like this, going into the membranes, right?
Mhm.
And your permeate is coming out from the membranes. And depending upon the module number, you have your permeate, right?
Yeah.
And your reject is passing through all the membranes and coming out from here, right?
Mhm.
So your reject is coming till here, and your permeate is coming till here, right?
Mm.
So if you think logically, the feed is divided into feed and permeate.
Yeah, it splits,
So if
basically.
if you add the volumetric flow rates,
Mhm.
in general, the total volumetric flow rate is nothing but the addition of permeate and reject, right?
Yeah.
And here the permeate flow rate is very low, such that that assumption is valid. In general, it's not valid because the compositions is different and the material balance is difficult.
Mhm.
It's invalid if both the flow rates are higher. But the permeate flow here is very low,
Mhm.
so it's valid. So your permeate, for measuring the gas flow rate, the stream needs to go into this valve, right?
Mhm.
This is connected to the digital volumetric flow meter, right?
Mhm.
So for measuring the gas flow rate, it should pass through this valve, pass through this thing, this meter. So your reject should go into here, and your permeate should go into here, right?
Mhm.
And these two should be closed. So remember this: if this is standing, it's open, and if this is sleeping, it's closed.
Open and close.
Open, closed.
All right. So
Okay.
when we basically turn this up, what you're saying is that the feed will go through here, and then this would be the permeate,
Yeah.
right?
Yeah.
And our reject would come up through here,
Yeah.
and we know that the permeate goes through here,
Yeah.
through this valve here,
Yeah.
and like this is where they meet.
Yeah.
Okay.
No. It depends upon our valve positions if they meet or not.
Mm.
Okay. It depends upon these four valves.
If they're open,
Yeah.
then they would meet,
Yeah.
and we would get
Yeah. Whichever stream passes through the volumetric flow meter gives you the volumetric flow rate, right?
the. Okay. Yeah.
So if you open these two and close these two, the reject comes in here and the permeate comes in here.
Yeah.
So technically you will be getting your feed flow rate, right?
Mm-hmm.
Am I right?
Yeah.
Yeah. So always remember this: one in these two should be open, and one in these two should be open every time,
One
just so
should be
that the
open?
system doesn't get pressurized.
Repeat that again.
One in these two valves
Okay, it should be.
and one in these two valves should be always open. Okay. So you know how to measure your feed flow rate now, right?
Mm-hmm.
Okay. So if I open this and if I close this, your reject stream will be going to the oxygen sensor, oxygen analyzer sensor, and your permeate stream is going into the volumetric flow meter, right? Because this is closed and your permeate stream doesn't have anywhere to go other than the volumetric flow meter, right? So you have your volumetric flow rate of your permeate stream and the oxygen concentration of your reject stream, right?
Yes, sir.
Yeah, this gives you the number. And if I do the opposite, if I open these two and close these two, the reject is going into the volumetric flow meter,
Mm-hmm.
and the permeate, it cannot go into the volumetric flow meter. It's going into the,
To the sensor. Yeah.
So this gives you the concentration of permeate stream, right?
Yeah.
So you play with these valves and you get the flow rates and concentrations. So remember this: when you're measuring the permeate flow rate, you're getting your reject concentration, and when you're measuring the reject flow rate, you're getting your permeate concentration, right?
Yeah.
And you adjust the pressure in here. You adjust the pressure in here by pressurizing it. You read the pressure in this gauge.
And that gauge right there.
Yeah.
Okay.
Okay. So that's what you're doing in this experiment.
That's it.
And you write the flow rate here, flow rate from here. I mean, you get the concentrations, you get the flow rates, everything, right? So you get the volumetric flow rate in liters per minute from here. You get a stopwatch. You take a reference point. You measure, then you get the number of revolutions taken. It's given in the manual that for 30 psi you need to do it for 1 revolution or something. See it in your manual. So depending upon the number of revolutions, you write down the time taken for 1 revolution,
Mm-hmm.
and you use the conversion factors to convert it to liters per minute, and they should match. Okay? Yeah, that's what you're doing.
That's it.
Yeah, that's it.